The pizza box. The pizza box pictured on the top of the page there, you can picture it two different ways. You can actually unfold it if you had a pizza box and flatten it out and then measure each corresponding piece. Or you could look at the pizza box, and as horribly artistic as I am not, I'm sketching it, kind of looking down on it. You can use those three pieces of information to find the surface area of the pizza box. So when I was holding that one box for you, I kind of made us think about the different shapes, or the different faces, if you will. The front and the back. So there's two of them, right? There's a front and a back. Two identical ones. So would it make sense to say that the area, and they're calling it top and bottom. I just drew it so that you're kind of looking down on it. See, here's my pizza. Pepperoni. Not very much pepperoni. So in order to solve the surface area of the front and the back, you're going to multiply 16 by 16, right? What do you get?
256. 256.
256. And if you double it, you have the front and the back's total. Right? 512? So the area of the front and the area of the back is 512, and we're dealing in inches, so it's inches squared. 512 inches squared. So I've already done the front and the back. They're calling it top and bottom. I just happen to have the box picked up. How about right and left? Here's the right. The left is identical. Right, left. And there's two of them, so it's 2 times the area of those, which is going to be 2 times 16. 32. Does everybody see how I got 32 for this? 2 times 16 gives you a surface area of 32 inches squared. Take that 32 inches squared and double it, because we just solved one. When we double it, we get the right and the left. 64. You guys with me so far? The only thing we haven't done is which spot.
I have a question.
Go.
Did you get 512 for the front and back? Would it be 5,100? Or
256 times 2?
yeah. Oh, never mind.
So we found the area 16 times 16, which you said was 256. And one of them is 256, so two of them, front and back, is 512. Thank you for asking. Did everybody hear what she said and cool with that? The last thing we have to do would be, I did front, back, I did right, left. What do I have to do now? Top, bottom. And since there is a top and a bottom, and they are identical, whatever the area for one is going to get doubled. 16 times 2. Incidentally, it's the exact same thing as the right and left, isn't it? Did you get 64 again? Now, if you had recognized that right off the bat and just said, well, I know that this and this and that are the same, if you did 4, if you did right, left, top, bottom, all the same, you're going to come up with the exact same answer. It's not any different. Okay? The sum of all of those numbers is 640 inches squared. And actually, not that you're going to wrap a pizza box, but back to the gift wrap thing, if you ever buy rolls of gift wrap, on the little plastic sleeve that's around it, it's going to say how much area that paper would cover. When you buy paint and you're painting a room, you're going to find how much area the paint will cover. That's what the bottle or the gallon thing will usually tell you. Okay? That's surface area in a nutshell. Okay? pizza box. Any questions on just this one? All right, here's a new word for you. The term lateral faces. What they are talking about when they use the word lateral faces, and the front and the back, right, left, top, bottom, those are all the faces of the pizza box or the Ziggy box over there, okay? Lateral faces are going to be, based on your perspective, faces that aren't bases, as in top, bottom. So, if I take this box and I set it right here, the bases are this and this. Everything else is considered lateral. Okay? If I stand it up, the bases are the top and the bottom. Everything else is lateral. It's about how it is figured, okay? That terminology is just used to represent what is where, okay? And it's completely dependent upon the arrangement of the object in question. Does that make sense, what lateral means? Mm-hmm. Okay. And what they've done at the top of page 539 is they've taken that same kind of box and they've stood it on end, and the pink, what they were able to shade pink for you, is the top and the bottom, and the rest of it, they've shaded it all blue. Okay, now you saw how I did the pizza box, right? I just took it apart, we added it all up. They call that in a lot of textbooks using a net. It's like unwrapping the object and finding the surface area based on the measurements that you're able to see. What we're going to learn here in the next section is that there is actually a formula that you can use that is a little bit easier than this if you get it. Okay, if you don't get it, the net method is always right. Okay, no matter what, you can always use find all the faces and add them together. But here's the new method, and this is in the middle of page 539. They give you a formula, and they've sketched us a nice box. They've given us a height of 10. This piece right here, they're going to call that a width, and we'll call that a length of 6. Okay, what they want you to know, another way of thinking about this, is the surface area is equivalent to twice the area of the bases added to the base's perimeter multiplied by the height. Okay, I have to put these little caveats in there because to me 2b plus pH doesn't tell me a daggone thing, okay? So twice the area of the bases. In this sketch, what we are currently looking at, that is a base, and that is a base, right? What is the area of one of the bases? Tina, are you able to see that? What is the area of one of these bases?
23.
Yep, she's right. And they want 2 of them. Why? That's what they tell us. Twice the area of the bases added to The perimeter of the base. Okay, still using the numbers 6 and 4. The perimeter is 6 plus 6 plus 4 plus 4, right? Does everybody get 20 for a perimeter? 6 and 6 is 12. 12 and 4 is 16. Plus 4 is 20. Am I doing my arithmetic correctly? I hope so. That's the perimeter of this base. Multiply the height, which is really obvious. They give it to us, of 10. Simple arithmetic then gives you a final answer to this shape. If you hate this method, you can always solve all the sides and add them together. And no teacher is going to tell you don't do that. It doesn't matter. I have never memorized this method. Okay, I'm going to tell you right up front, I am a pizza box person. But if you want another method, this is another method. Okay? If you can remember this method, great. All right. Did everybody get enough of this copied? Can I flip? So, what if we have a prism that is triangular looking, like example 2? I am terrible at drawing these. I'm going to do my best, but it's not going to be pretty. There's got to be a way to do this without these looking so shabby. Mine are always shabby.
You draw 2 triangles and you connect them.
Connect them?
Mm-hmm.
That's not too bad. Probably the best one I've ever drawn. Yeah, that's not saying much, by the way. The hypotenuse appears to be 10. And I know it's a right triangle because they labeled it as such. 6, 8. And then from here to here is 18 centimeters. We can do the pizza box method, but let's use the method they've given us and try and ascertain the values, plug them in, and see if we can't go from there. And I think this one is really a good example for that method. The surface area is equivalent to twice the area of the bases added to the perimeter of the base multiplied by the height. And remember how I said the base is subjective? It's your perspective. Well, notice right now they've got that triangle thing laying down. And this isn't a triangular prism, I'm sorry. But what if I set it like this? These two parts become the base, right? Mm-hmm. Let's pick up that prism. And I am not going to try and draw it in an upright position because it ain't going to happen. But we're going to pick it up. Okay? So now instead of it laying this way and having the triangles facing us and away from us, we're going to have the triangles being the spot that's in the air and the bottom. That means the triangles are the bases. So this is a base and this is a base. So the area of one of the triangles, base times height divided by 2, right? Area of one of the triangles, 6 times 8, which is 48, divided by 2 is 24, right? So this one's 24 and that one's 24. Some of you right away are going to say, why did I even divide it by 2 then if I'm just going to multiply it by 2? But whatever works for you. Okay, each of these is 24. Now, rather than do the surface area of that flat slope and then the other 2 sides, we're going to use the perimeter of the triangle, that's perimeter of the base, multiplied by the height. So it's 6 plus 8 plus 10, am I right? 10, 18, 19, 20, 21, 22, 24? Did y'all come up with 24 there? Okay. The perimeter is 24. 8 plus 6, there's the hypotenuse, so it's 10. perimeter of the triangle, perimeter of the base, multiplied by the height of 18. So 48 added to whatever 24 times 18 is. And they have it broken down in the book. If you need to really like double check all those numbers, you can. So the perimeter of the triangle multiplied by the height is this. The product of two of the areas of the bases is that. And the sum of both of those areas is 480, and it's in centimeters, and area is always units squared. So centimeters squared, feet squared, etc. Okay? Checkpoint 1 or 2. Which one do you want to do? You want to do 2? Are you guys okay with not doing 1? Because here's 1. Stand it up like this. Okay? Picture, that's the shoebox model. So let's do checkpoint 2. I wish I could draw it better, guys. I'm sorry that I can't. Maybe some of you are better at it than I am. I'm hopeful anyway. Not too bad. We're going to pretend it's matching. They give us this little piece of information here for, that's the height of that triangle. And they give us one of the sides is 5. They give us, hold on, I lost my place, 6 meters. So I know this one's 5 as well. And they give us 12. You know what I find kind of strange about this one? Is that they don't give us the other side.
They already gave us 5 for 1.
Oh. So you're saying that this is an equilateral or a isosceles triangle because they gave you that information. Good. Okay. I don't know if you all heard what Haley said, but they gave us this 5, and because of how they drew this, it's almost implied that this is an isosceles triangle. So because it is an isosceles triangle, we know that the sides are 5, 5, and 6. We'll do the yellows for the bases. Area of the base is 30 because 2 15s are 30. So let's do it. 2 of the areas of the bases added to the perimeter multiplied by the height. So the areas of the base is 24 because 6 times 4, 12. 2 12s is 24. The area of this triangle is base times height, 6 times 4, 24, divided by 2 is 12, and there's 2 of them. You good so far? Mm-hmm. Those are the 2 yellows. Now the perimeter of the thing.
15.
5, 10, I'm getting 16. 5, 10, and 6. This is a 5, that's a 5, and that's a 6. So 16 times 12?
$216.
If you came up with 216, you are right. So just to review, we did double the bases. So each bases are triangular, so it's base times height divided by 2. So one of them's 12, and the other one's 12, for a sum of 24. To solve the remaining portion, the instructions are perimeter times height, and that's perimeter of the base. The base's perimeter was 5 plus 5 plus 6, and we figured out this 5 because it's an isosceles triangle. 5 plus 5 plus 6. All of that got multiplied by the height of 12, gave you the 216 meters squared. Okay, moving on. Cylinders. So you guys were wondering why I was painting on a paper towel. If you did, if you noticed, if you didn't, that's okay too. The exact same rules apply. It's very, very similar. So if I want the surface area of this, I need the area of the top, which is a circle, added to the area of the bottom, which is the same circle, and I need the surface area of the curve that you can see, which I painted, just to kind of give you an idea. It's a rectangle. When I peel the surface area of a cylinder off, it is a rectangle, which is why the formula that we just got through using for the surface area of prisms also works for what we're doing with cylinders. Okay? Paper towel back on. The formula they provide for us, and the sketch they give is also quite cool, I think. Theirs is probably a little clearer than my paper towel model, but if you look at a cylinder, it looks something like this, and if you unwrap the paper towel like I did, you have the area of the top portion of the cylinder, the area of the bottom portion of the cylinder, and then the part that wrapped, that made this curve, unwrapped, is a quadrilateral. Okay, it's a rectangle of some sort. So, to find this information out, you can do the exact same thing. The surface area is twice the area of the bases, so top and bottom. Normally cylinders are going to sit on that anyway. Added to the perimeter of the circle, which in circles is called circumference, right? That's why it's C, multiplied by the height of the object that we're talking about. So let's use their object. They have a radius of 4, and they have a height of 10. So the bases are circles, so it's just pi r squared, right? Area of a circle is pi r squared. Circumference of a circle is pi d. Okay, pi d. So let's do areas of that circle. Pi r squared, so pi times 4 times 4, pi times 16. What do you guys get when you do 16 times pi?
50.24.
16 times pi?
50.26.
Okay, 50 point, yeah, that's fine. You just didn't use the pi button. I thought you said 15. 50.24. So, for sake of argument, we'll say 50. 50 and 50. So we're doubling the bases, and in the end we're going to have 100, right? This, in order to do this, we have to have the circumference of the circle and multiply it by the height. How do we find circumference? Pi times what?
Diameter.
Diameter is what?
10.
8. Good. Pi times 8. 8 times 6. And I'm using my pi button, so, which is 25-ish. Did you all get 25-ish? Doesn't round up because it's 25.1. Multiplied by the height, which is 10. They're getting 352 units.
I don't know why they're getting another 2 units. They're probably using the second one, which came a lot closer.
Pi times diameter, 3.14 times 8 is that. Circumference times the height, which they said is 10. That's that. Huh. All right, well, we're getting 350, they got 352.
You can do the second one, get this.
Yeah. If you plug it in the way they plugged it in, using pi every time and not rounding, you'll get that. Or you'll get their answer. But I rounded, so I got this. By the way, if you get me an answer that's 1 or 2 off, one way or the other, I'm not going to mark it wrong, because that means you rounded just like I just did. Okay, does that make sense? Okay. That is a cylinder. Why on earth, example 3, you would care about finding the surface area of a racquetball can is beyond me, but let's find out. Let's find out. Racquetball can. All of my cylinders look exactly the same. It looks to me like they gave us diameter. Would you agree?
Mm-hmm.
And the height is 5. Surface area. The only change is they use the word circumference instead of perimeter, because circumference is measurement around a circle, just like perimeter is measurement around a polygon. Surface area is twice the area of the bases added to the perimeter of the circle, which is the circumference, times the height. Bases area, pi r squared. So what's 2.5 cut in half?
1.25.
1 1/4? 1.25 times 1.25 is that. I got 1.5625 multiplied by pi. And I get 4.9. So 2 of the 4.9s, that's the bases, okay? Bases are pi r squared. So pi times the radius squared, which is 4.9. The circumference is pi times diameter. The diameter is 2.1 or 2.5. Pi times 2.5. Shift. Do you get 7.85, 7.9? Did you guys get that? Something like that? Okay. The height at least is easy. All of this added together. I can't write my calculator, it gives me goofy answers. If you add double the bases and the product of the circumference, which we got here, and the height, which we got here, you get 49. I got 49 3/10. They got 49 1/10. Anybody get anything other than that? Like 76 or anything weird? So somewhere in the 49s is what you should have gotten. Okay, I'll give you the rest of this time to get started. Mm-hmm.